Download this code from codegive.com, link in the description below. In recent years, vector databases have gained popularity due to their ability to handle unstructured data, such as text, images, and audio, by representing them in a high-dimensional vector space. Opensearch, an open-source search and analytics engine, has incorporated vector search capabilities, allowing users to perform similarity searches on embeddings generated by machine learning models. What is Opensearch? Opensearch is a community-driven project that originated from Elasticsearch. It provides a distributed search and analytics engine that is highly scalable and designed for a variety of applications, including log analytics, full-text search, and real-time analytics. Why use Opensearch as a vector database? 1. Scalability. Opensearch can handle large datasets and scale horizontally. 2. Search capabilities. It provides advanced search capabilities, including text search, filtering, and aggregations. 3. Vector search. Opensearch supports KNN, K-nearest neighbors, search, which is essential for finding similar items in vector space. Setting up Opensearch. 1. Installation. You can run Opensearch locally using Docker or install it directly on your machine. Here's how you can use Docker. 2. Verify installation. Open your browser and navigate to http://localhost 9200. You should see a JSON response confirming that Opensearch is running. Using Opensearch for vector search. Step 1. Indexing vectors. To use Opensearch for vector search, we first need to create an index that supports vector fields. Below is an example of how to create an index with a vector field. Step 2. Indexing documents. Next, we can index some documents with their corresponding vectors. For the sake of this example, we will use random vectors. Step 3. Performing vector searches. Now that we've indexed our documents with vectors, we can perform a vector search to find similar documents. We will use a random vector as our query. Conclusion. Opensearch provides powerful capabilities for managing and querying vector data, making it an excellent choice for applications that require semantic search, recommendation systems, and more. The above example demonstrates how to set up an Opensearch instance, create an index for vectors, index documents, and perform vector searches. Next steps. 1. Explore advanced features. Investigate Opensearch's advanced features, such as filtering and aggregations. 2. Integration. Consider integrating your Opensearch instance with machine learning pipelines for dynamic vector generation. 3. Security. Implement security measures, such as authentication and authorization, especially in production environments. By leveraging Opensearch as a vector database, you can effectively manage and query high-dimensional data for various applications. Opensearch is an open-source search and analytics suite derived from Elasticsearch. It includes features for full-text search, as well as recent capabilities for handling vector data, making it a viable option for use as a vector database. This tutorial will guide you through setting up Opensearch, indexing vector data, and performing vector searches. Prerequisites. 1. Docker. Ensure you have Docker installed on your machine. 2. Opensearch. This tutorial will use the Opensearch Docker image to set up your environment. Step 1. Setting up Opensearch. You can run Opensearch using Docker. Here's a simple command to start Opensearch. Once Opensearch is running, you can access it at http://localhost 9200. Step 2. Creating an index with vector support. You need to create an index that can handle vector data. This can be done using the following API call to Opensearch. Step 3. Indexing vector data. Now that you have an index with vector support, you can index some vector data. Here's an example of indexing documents with three-dimensional vectors. Step 4, Performing vector searches. To perform a vector search, you can use the KNN, K-nearest neighbors, search query. Here's how you can search for the nearest vectors to a given query vector. Step 5, Analyzing the results. The results will include the documents that are most similar to your query vector. The score field will indicate how closely each document matches the query vector based on cosine similarity. Summary. In this tutorial, we covered the following. 1. Setting up Opensearch using Docker. 2. Creating an index with vector support. 3. Indexing vector data. 4. Performing vector searches using KNN. You can build upon this foundational knowledge to implement more complex use cases such as recommendation systems or semantic search applications using Opensearch as a vector database.